I promised you all a video over some of the stuff that we didn't quite get to, and we'll look at it at the start of class this week, but I promised you, so even though it's getting kind of late on that promise, I still want to kind of provide it. So, we're supposed to have class tomorrow. I'm going to try to get these recorded and added to our MyLabs Plus Classroom. So we were looking at law of signs and the ambiguous case. And here we have that angle A is 30 degrees, side length A is 7, and side length B is 16. So this is just an example that I've made up that I am pretty sure is going to cause problems. But like if you didn't know that in advance, you might doodle some kind of triangle, pretend I can draw. And you would say, okay, maybe I know that this angle is 30. And if that's angle A, then side length A would be over here, 7. And let's say I decide that this is angle B. That means that side length B would be right here, would be 16. This would be angle C. And the idea is that because we have an angle not included by the two sides, that's what causes problems with these problems. Also, as a reminder, to attempt to solve it, because it's an oblique triangle, no right angle, we would use law of sines. So I probably should have already written that on the slide. And again, you don't use this all at once. You don't use all three parts. You think about what you know and you try to use two of the three parts to solve. So we know side length A and angle A, and we know little b, we know side length b. So we would use a version that uses the a's and the b's. So we would say that sine, that is so bad, I'm going to start that s over. Sine of 30 degrees divided by 7 would equal sine of an angle compared to a side length. The other side length that we know is 16. So this would be angle B. So the first thing we would try to figure out is angle B. And once we know angle B, we might be able to figure out another side length because we'll be able to decide what angle C is using angle B. From there, it's largely a calculator problem. So you're going to do on a calculator, make sure you're in degrees, sine of 30 divided by 7. And that ends up being, my calculator just died. My calculator just died. Give me a moment. I'll use the one on my phone. So a little clunkier. Live action. Sine of 30. Let's make sure I'm in degrees. Divided by 7 is about 0.0714. So erase this little stray mark right here. That would roughly equal sine of b over 16. We would multiply the 16 to the other side, so I'm just going to hit times 16, and you would get 1.143. For sine of b. Because we know the ratio and want the angle, this is have the calculator look it up for you. This is an inverse sine problem. That's a terrible 3. That B ain't great either. Yeah, so that's approximately equal angle B. Well, here's the problem. If you attempt this and do inverse sine of 1.143, or just the number on the screen, your calculator will do something along the lines of error. It might say like domain error. It might say just error. It should make it clear that there's a problem. And in case you have kind of forgotten, because we talked about the idea that the trig's really coming from the points on the unit circle. It's a pretty good circle. You might kind of recall that we said that when we draw the little triangle and everything, that y was the sine of the angle. So the y coordinate of the points on the unit circle would always be between -1 and 1. And since the y coordinate would always be between -1 and 1, sine of an angle is always going to be between -1 and 1. So sine of some angle being more than 1 can't happen, and that's why you get this error message. All right, that's it for this example. So the short version is, if you're working a law of sines problem and it's an angle side ambiguous case problem, there may not even be answers. And a good way to spot that you're about to be in a situation where you're going to realize that the triangle can't really exist is if you try to do like inverse sine of a number that's more than 1. What's happening here is that in real life, the relationship between the angles and the sides is such that something like this is going on where it won't actually complete a triangle. I don't know if it's an acute angle, it might look like this and just way too short. If it's an obtuse angle, it's still going to be the idea that this side's too short. And it's happening in this triangle. So it never would have ever looked anything like this, it turns out. You can't build a triangle where this angle's 30, this side is 7, and this is 16. No matter what you do with these angles and this other side length, it won't matter. It won't ever actually make a triangle. Bye for now.